remember that direct, the formula is y equals kx. For direct, y equals kx. And for inverse, the formula is y equals k over x. Okay? So don't forget, those are your two formulas. Okay? Number one, a spring extends or compresses in direct proportion to the mass being supported. All right, I'm going to stop right there because while I'm reading, there's something that's important. What's important? Direct. Okay, so as I'm reading, I'm going to circle that. Okay? If spring A extends, this should be a 13. I know it didn't copyright. All right, if a spring extends 13 centimeters when supporting 100 grams, how far will it extend when supporting 20 grams? Okay, so let's go back up to the first sentence. A spring extends in direct proportion to the mass. All right, so let's start our formula. So I'm going to use an E for extends. I'm going to use an E instead of a Y, and then I'm going to put it equals. K always comes next. And then for direct, do I put the next variable underneath it or beside of it? Beside of it, okay? And so my next variable is mass. And so I'm going to use the letter M, okay? All right, so let's see what numbers they give us. If spring A extends 13 centimeters, so 13 goes in for what letter? E, okay? It extends 13, so 13 goes in for E. Remember, I don't ever know my K at the beginning. 100 grams is a mass, okay? What's another word for mass? How much something weighs, okay? So 100 goes in for mass. All right, same steps as yesterday. You got to figure out what K is. Divide both sides by 100, okay? 13 divided by 100 in your calculator is giving you 0.13, okay? All right, take that, plug it back into the original. So E equals, and I now know what K is. K is 0.13 M. Okay, so same steps as yesterday. Then we have to go back and read the question. How far will it extend when supporting 20 grams? Okay, is 20 grams an extension or a mass? It's a mass. Okay, so I'm going to plug it in. 0.13 times 20. All right, 0.13 times 20. What's the calculator telling you for that one? 2.6. Okay, 2.6. All right, so that's your answer to that one. Okay. Number two, the change in Fahrenheit temperature varies directly as the change in Celsius temperature. If a temperature difference of 5 degrees Celsius produces a temperature difference of 9 degrees Fahrenheit, what change in Fahrenheit would be produced by a change of 35 degrees Celsius? Okay. All right, go back to this first sentence. The change in Fahrenheit temperature varies directly with the change in Celsius, okay? What are the two things I'm comparing in this problem? Fahrenheit and Celsius, okay? Fahrenheit and Celsius. So I'm going to start with the letter F for Fahrenheit, okay? I'm going to start with the letter F for Fahrenheit and put equals. And then varies directly. If I look back up at my formula, what letter comes next? K. And then instead of putting X, what am I comparing Fahrenheit to? Celsius. That's my other variable. So Fahrenheit and Celsius are your two variables. Okay? All right. Let's see. The first number they give you is 5 degrees Celsius. So 5 is going to go in for C. 5 is going to go in for C. And then 9 degrees Fahrenheit. So 9 goes in for F. Okay? Goes in for F. All right. What do I do to both sides? Divide by 5. Okay. All right. What are you getting K to be? 1.8. Okay. All right. You've got to plug that back in. So F equals 1.8 C. Okay. So you're putting 1.8 in the K spot. All right. Go back and read the question. What change in Fahrenheit would be produced by a change of 35 degrees Celsius? Where am I plugging 35 in for? C. Okay, it's going in for Celsius. So 1.8 times 35, because that one goes in for C. What are you getting for your answer? All right, 63 degrees. Okay. All right, number 3. At a constant temperature, the pressure of an ideal gas varies inversely with its volume. If a gas occupies 6 cubic inches at a pressure of 20 pounds per square inch, what is the pressure if the volume is decreased by 2 cubic inches? The temperature remains constant. Okay. All right. What's my keyword? Good. Varies inversely. That should be circled, underlined, highlighted, something. Okay. What 2 things are you comparing? What are the 2 things that vary inversely? Well, kind of, but just go back to that. Look at the words varies inversely and go to the left of it and to the right of it. So go to these words varies inversely. Go to the left. What are we talking about? The pressure. Okay. The pressure varies inversely with the volume. Okay. All right, and let's set up our formula. So what you got to do first. So I'm going to use a P for pressure equals, what letter comes next? K. Good. And this time, since it varies inversely, you put a divide sign with the volume. Okay, so that's your formula. Okay. All right, what's the first number they give you for pressure? 20. Okay, it says a pressure of 20, so 20 goes in for pressure. And what number goes with the 20? The 6. Okay, so 6 goes in for your volume. Okay, goes in for your volume. Okay. All right, what would you do to both sides to get K by itself? Multiply by 6. And so you get K to be 120, okay? Plug it back in. P equals 120 over V, okay? All right, what is the question asking on this one? All right, what is the pressure? That means I don't know what it is. When the volume is what? Oh, good, Brian. It's decreased by 2, okay? It's not 2, it's decreased by 2. What was the original volume? 6. The original volume was 6. If you decrease by 2, you are at 4, okay? You're at 4. So P equals 120 over 4. So your new volume is 4. And what does that give you? Gives you 30, okay? All right, number 4, the rate of travel over a fixed distance varies inversely with the time. If a runner travels at a rate of 1 mile per hour in 5 minutes, how fast is she running if it takes 4 minutes to cover the distance? Okay, all right, keywords. Good, varies inversely. Okay, all right, and you have to be careful on this one. What does it tell you about the distance in the very beginning? What word do they use to describe the distance? Fixed. What does fixed mean? It stays the same. It doesn't change. So we're not going to be plugging numbers in for that if it stays the same. Okay. All right. So the fixed distance isn't going to matter. What 2 things are we actually comparing? Good. The rate. We're comparing the rate with the time. Okay, we're comparing the rate with the time. So start with your R. R equals K. All right, for varies inversely, do I put a divide sign or multiply? Divide, okay, and I'm dividing it by the time. Okay, divide it by the time. All right, the first 2 numbers they give me are 1 and 5. Is 1 a rate or a time? A rate. And 5 is a time, 5 minutes. Okay? All right, to get K by itself, you do the opposite of multiply, so times by 5. So K equals 5. Okay? All right, plug that back into the original formula. R equals 5 over T. Okay? All right, what's the question asking? If it takes how many? 4 minutes, okay? Is 4 minutes a rate or a time? Time. Okay, so R equals 5 over 4. Okay, you could leave your answer like that, or you could put 1.25. Okay, either way is fine. Either one would be counted right. Okay. All right, number 5, heart rates and lifespans of most mammals are inversely related. A cat lives for about 15.2 years on average and has a heart rate of 126 beats per minute. If a hamster has a heart rate of 634 beats per minute, how long will a hamster live? Okay, what was a key word in there? Inversely, okay? Look in this same sentence. Look in this same sentence. What are the two things that we're comparing? Good, heart rates and lifespan. So let's set up the formula. So I'm going to use an H for heart. I'm going to use an H for heart equals K. Good, inversely means I'm putting a divide sign. I'm comparing it to lifespans, okay? All right, now you have to be careful. What's the only thing they tell you about a hamster? They give you, what do they tell you about the hamster? They give you its heart rate. Is that enough information to work a problem? No, you need to go back and use the numbers for the cat. You've got to go back and use the 2 numbers for the cat, okay? All right. Let's see, they say a cat lives for 15.2 years. So 15.2, is that the heart rate or the lifespan? The lifespan. So K over 15.2. And then it says it has a heart rate of 126. Okay, so you plug in your 2 numbers, the 15.2 and the 126. All right, multiply both sides by 15.2. And you get K to be... Good, 1915.2. Okay. All right, so plug it back in to the original. You get that, okay? And this one says if a hamster has a heart rate of 634. So 634 is going in for what letter? H. 634 is going in for H. All right, so 634 goes in over here. Whenever your variable is on the bottom, that's when you're going to have to do the what method? What do you have to do when there's a variable on the bottom? Yeah, you got to do the 1 in the butterfly thing, okay? So I put a 1 underneath the 634, and I do the butterfly. So 634 times L is 634L. And then 1 times that is just that. Okay? And all you have to do is one more step. It's not that hard. Okay? What do you do last? Divide. Divide by 634. Divide both sides by 634. Alright, what do you get when you divide by 634? L equals, yeah, let's do 2 decimal places. So 3.02. Okay, 3.02. All right, if an elephant lives for about 70 years, how many times per minute does an elephant's heartbeat live? Or how many, what does it say? How many times per minute does an elephant's heart beat? Sorry. Okay. What do you think we're gonna, what shortcut can we take on this one? We can plug 70 into what? Into this equation right here, the equation we already came up with. So 70 years goes in for H or L? Okay. 70 years, we're going to plug it into this formula. So H equals 19.15.2 over 70. Okay? Just type that in your calculator and divide. Alion, what's your question? Okay, here's why. So, the heart rate is different. But look what it says. It says heart rates and lifespans of mammals are inversely related. So basically, we found out what K was, and you can use that same K for every animal. You just have to plug in its specific lifespan or its specific heart rate. But the K is constant. Okay, so we're using the same K, but we're plugging in the 70 that deals with the elephant. Okay. All right, number 6. The number of possible string sections to be cut from a 4-inch piece of string varies inversely with the length of each of these string sections. Which equation models this relationship? What's the key word? Varies inversely. So I can automatically mark out some stuff. I can already mark out some stuff. Yep, I heard C can be marked out. Andy, why can those two be marked out? Inversely, if you go back up to the top of your paper, inversely has what kind of thing in it? Division. Inversely is divide. Okay? Inversely is divide. Which one is it? A or B? Why? Why is it B? It is B. It's B. Why is it B? Why should L be on the bottom? All right, because it's length. What else? Why is it B? Good. Okay, so 4 inches are, every time we're cutting, are we always starting with a 4-inch piece of string? Yes, you're always starting with 4 inches, which means 4 inches is K. Why is it K? It's constant. Okay, 4 is your constant. Okay, that goes on top. All right, last one. Suppose the price of pizza varies directly as the square of its diameter. At Jack's Pizza Parlor, a 16-inch pizza costs $14.50. How much less would a 14-inch pizza cost? Okay. All right, guys. This one, students miss every single time on the test. They always miss this one. Here's why. What's the key word? Varies directly. Okay. And what 2 things are we comparing? The price and the size of the pizza. Good. Okay, we're comparing the price and the size of the pizza. So the price, P equals K. All right, for varies directly, do you multiply or divide? Multiply. Okay, here's what always gets people every semester, even the honors. It says, it's this right here, the square of the diameter. So you have to put D for diameter, but what do you have to put with that D? A square with it, okay? You have to put a square with it. Okay, so you work it the same way. So first of all, what's the first price they give you? $14.50, okay, that's the price. K times, what's the diameter of that pizza? All right, it's a 16-inch pizza, so that's your diameter, and you have to square that. All right, your calculator will do all the work. You can type in 14.50 divided by 16 squared, and you get K to be what? Let's go 2 decimal places, so point. 6. It'd be 0.06. Okay. All right, guys, please watch. We're almost done. Please watch this. I'm going to write P equals, what do I know K is now? 0.06. And then I'm going to put D squared. The squared, it goes with the whole problem, okay? So you plug 0.06 in, but you keep that D squared, okay? All right, the question says, how much less would a 14-inch pizza cost? Is 14 inches a price or a diameter? A diameter. 14 inches is a diameter, so 0.0614 squared. 0.0614 squared. All right, so how much does this one cost? All right, $11.76. And then DC pointed out earlier, it does say how much less. So how much was the original pizza? $14.50. And then our new pizza is $11.76. What do you have to do with those two numbers? Subtract. What do you get? 276.